Today we're going to talk about trapezoid. Jason, what do you think? How do you think we're going to define trapezoid? We sort of talked about this when we were talking about parallelogram a little bit. Any guess?
Quadrilateral.
Good.
With one pair of parallel sides.
Yeah, they say actually exactly one, because they don't want you to think that it could be two, right? So this is how we define a trapezoid. A quadrilateral with exactly one pair of parallel sides is called a trapezoid. Along with the definition, they tell you something about the two parallel sides. It's got a name for them. Anybody want to guess what they're called? Yeah, base. Exactly. These are the bases. The two parallel sides are the bases, and the other sides are the legs. Okay. What does that remind you of?
Triangle.
Triangle. Yeah, exactly. So here's a picture. So you got the two bases. The one on the left is what a lot of people are used to. Could we have the base sort of vertical like this? Is that okay? Yeah. Still a trapezoid, isn't it? You have one pair of opposite sides, right? Parallel, and then exactly one pair opposite side parallel, and then you got the other two legs. You don't have to draw it, but I want you to understand that trapezoid. It doesn't have to look like this on the left. You know what I mean? It could be vertical. The two bases could be vertical. Also, look at all the angle measures. If you were to add up all the angle measures of a trapezoid, since it's a quadrilateral, yeah, it should add up to 360, right? So that should be pretty straightforward. You guys see anything interesting about these angles? 140 and here it's 40. Yeah, aren't these same side interior angles? And what do you know about two parallel lines cut by a transversal? Then the same side interior angles are supplementary. Look, here's 100, here's 80. Hey, look, it's 70 and 90. How come it doesn't add up here? Yeah, these are not the same side interior angles. Here, remember the river? These are the river goes this way. So here's a transversal. 70 and 110, it adds up to 180. Here's 90, 90, right? This happens to be perpendicular. Okay. Any question? Does that make sense? That's sort of nice. Okay. Anybody want to guess then what an isosceles trapezoid might be? Yeah, John. What do you think?
It's a trapezoid where the legs are congruent.
Exactly right. So here's an isosceles trapezoid. If you haven't, it's sort of obvious. Okay. So, sort of like what? Isosceles what? Triangle, right? It's a trapezoid with congruent legs. Okay. It's called an isosceles trapezoid. As you can see, you got the two legs congruent. Okay. Would it be an isosceles trapezoid if it has congruent base? No. If it did have congruent base, what would you have? Yeah, you would have a parallelogram, not a trapezoid, right? Because then that would have to have, right? Remember the theorem that says what? If the sides are both congruent and perpendicular, congruent and parallel, then you have a parallelogram, right? So it has to be the legs that are congruent. By the way, why do you think all of a sudden we talk about the isosceles trapezoid? Yeah. We're going to have a theorem for it. Anybody want to guess? It's sort of like the isosceles triangle theorem. It's very similar. Nicholas, you want to guess? Well, we don't have a name for it, turns out. But what do you think this is going to say? You're right. It's sort of the same way.
It's going to say that if the two sides of a triangle are congruent, then the opposite trapezoid are congruent, and the opposite angles are also congruent.
Not quite. It's actually a little bit simpler than that. Nicole? So when you say two sides of a trapezoid are congruent, you could just say if you have an isosceles trapezoid, what? Right. What do we call those angles?
Legs.
No? Say it again? Base angle. Yeah, exactly. So it turns out, by the way, here's the picture.
It's that simple.
Yeah, it's that simple. It just, whoops. It just says the base angles of an isosceles trapezoid are congruent. That's it. How many base angles do you see? How many say 2? Raise your hand. How many say 4? You guys are correct. There are 4 base angles. How come? Didn't we only have 2 base angles for an isosceles triangle? How come this time we have 4 of them? Yeah. There we have 2 bases, right? So what are they? Angle X and Y. Those are the base angle. That's one pair. That's sort of obvious. What are the other ones? B and yeah. So look, be careful. So some people they forget to think about the base angles up here. Okay. So we're saying X and Y are congruent and angle B and A are congruent. Are we saying all 4 of these angles are congruent? No, right? If it was, then you have a rectangle, right? Okay. So yeah, we're only saying is look X congruent to Y. There's a semicolon and then Y angle B congruent to angle A. Okay. So these pairs are congruent. Not all 4 of them are congruent. Okay. Any question? Yeah. Exactly. That's what we're going to think about. So anyone guess how we might be able to? Do you think drawing an auxiliary line is going to be helpful for this one? Yeah. So there are many ways of drawing the auxiliary line. One of the way, let me show you. Doing it this way. Okay. So how do you think we're drawing this auxiliary line BZ? Amy, what do you think? How do you think BZ? How do you think the BZ will be drawn? Exactly. We want to draw BZ so that it's parallel to AY. And some people ask, well, so what are you going to say if you're going to have to do that? Kevin?
Draw BZ parallel to...
Yeah, and then what's the reason going to be? This will not be through any 2 points. There's exactly one.
A point outside.
Yeah, a point outside our line. There's
exactly one line.
That's right. There is exactly one line that's parallel. Right? So that's your reason. Are we okay? Yes.
So from a point outside the line.
Yeah. Look, B is outside the line AY. Right? There's a line there's exactly one line that's parallel to that line AY. Are we okay? So that's great. So how are we going to show? By the way, what do we want to show again? We want to show that angle. Angle 1 is congruent to angle 3 and angle B is congruent to angle A, right? When we say B, we mean XBA, right? Because even though there's... Okay, so how would you do that? Oh, some of you see it? Okay, go ahead. I want you to think as a group. I'll give you time. What are you going to do? Discussing and so forth. That was good. Okay, so who could tell me... By the way, why does it say ABZ is a parallelogram right underneath here? Is ABZ a parallelogram? Yeah, it is. Okay, that's going to be helpful. And Andrew, why?
Because then you can use it to solve the
Right? Why? So okay, so how many people agree that ABZ is a parallelogram? Okay, why? So who could tell me why? Kristen, why?
It's a joke.
Yeah, by the definition of a parallelogram, right? You got both opposite sides parallel. Andrew, you said then, so that's going to be helpful. Why? Which part of the parallelogram? So what? So since it's a parallelogram, AYN. Good. We know that opposite sides of parallelograms are congruent. So AY is congruent to BZ. But how is that going to help us to show that angle 1 is congruent to angle 3? Eamon? You could show that BXZ is an isosceles triangle. But right now, we know that BZ is congruent to AY. We don't know much about BX and BZ yet, right? So you're right. If I could show that triangle BXY is an isosceles triangle, that would be helpful. How are we going to do that? Eamon? BZ is congruent to? Yeah, how? How are we going to do that? Good. We know that AY is congruent to BZ because of parallel. Good. And we know that AY is congruent to BX because what sort of trapezoids do we have? An isosceles trapezoid. So by what class? By which property can we say BX is congruent to BZ? By transitive, right? By transitive, we know that BX is congruent to BZ. So what? We got the size congruent. Okay, that's great. We have all three BX, BZ, AY congruent. But that doesn't tell me anything about angle 1 and 3, does it? It does? Okay, good. Who could tell me? Ye-chan?
Since they're congruent, if you use isosceles triangle theorem, you say angle 1 is congruent to angle 2. Angle 3 is congruent to angle 2 because, of course, if two parallel lines are cut by
Very good. That's what a lot of people actually have in their heads, but they're not saying it. We know that angle 2 and 3 are congruent also, right? Because if two parallel lines are cut by a transversal, I mean these two parallel lines, sorry, AYN, BZ cut by XY, right? Aren't angle 2 and 3, aren't they corresponding angles? So if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So therefore, you know that 1 and 2 are congruent, 2 and 3 are congruent. So what do you know about 1 and 3? By transitive, they are congruent. So that's great. But then what about angle A and angle B? So we know that these two base angles, but what about this whole angle, angle A and then angle ABX? How are we going to show that they are congruent? You know what I mean? Because okay, there are two pairs of base angles, right? Nicole, what are you going to say? Did angle, which ones? A and? They're not congruent.
No, but is it?
Angle A and angle 3, you mean, right?
Yeah.
They're not congruent, are they? They are what? But they are?
Supplement.
Yeah, they're same side interior angles, aren't they? So what do you know about them? They are? Supplementary, good. What about angle B and angle 1? They're supplementary. So anybody know a theorem that says something about... Okay, Austin, go ahead.
Two angles are elements of the same angle. Pair of congruent angles, then the angles are congruent.
Right, if two angles are congruent to the congruent angles, then if two angles are supplementary to the congruent angles, what do you know? Those angles are congruent. So you know that angle B and angle A are congruent. Any questions?
Wait, what was the step before that?
Which step?
How would you like know that?
Angle 3 is congruent to angle A.
Yeah, so you have to show that angle 1 is congruent to angle 3. Isn't that what we just did? By saying that this is an isosceles triangle, right? BZ congruent to AY, right? And since BX is congruent to BZ, we know, okay.
But first we have to say angle A and angle Y.
Yeah, so you,
Sides.
right, exactly. You have to say that angle A and angle Y are supplementary angles, right? I mean, hello, not supplementary. They are same side interior angles. Yeah, question?
Wait, so after you prove that angle 2 and angle 3 are congruent, can you just say that with the Isosceles theorem?
That's what we're trying to prove.
Oh.
Yeah. This doesn't have a name though. This doesn't have a name. Okay, so don't call it an isosceles trapezoid. It's not. That's not what it's called. It's just you have to actually go by the name. I mean not the name. Go by what it says. Base angles of an isosceles trapezoid. Is that okay? Any questions? Okay. You could also do it this way too. You could draw an auxiliary lines this way and prove. Okay. So actually, it's not that bad. Let me show you. It turns out I'm going to draw BP perpendicular to XY and AQ perpendicular to XY. If I do that, right, that's how I'm going to draw the auxiliary lines. Then you know that this is 90, this is perpendicular, right? So we know BX is congruent to AY because you have an isosceles trapezoid. What do you know about BPQA? What is that? Yes. It's a rectangle. How do you know? Well, actually, before a rectangle, you're going to say parallelogram. How do I know it's a parallelogram? Because I know that BA is parallel to PQ, right? PQ is parallel of XY. How do I know BP is parallel to AQ? Samantha?
Because BP and AQ both form right angles with XY.
Yeah.
There's a theorem that says if they both form right angles, then
Right. If two lines are perpendicular to the same line, then what do you know? They're parallel. So we know that you have a parallelogram, right? We don't need actually a rectangle, do we? So we have a parallelogram. If you have a parallelogram, what do you know about BP and AQ? Josh? Why? Opposite sides of a parallelogram are congruent, right? So therefore, by what are these two triangles congruent? Yeah. HL. We have a right triangle, right? By HL, the two triangles are congruent, right? Because we got BX congruent to AY, BP congruent to AQ, and then you have, it's a right triangle, both of them. And so BX is the hypotenuse, AY is the hypotenuse. Since the two triangles are congruent, what can you tell me about angle X and Y? They are congruent, right? Those are the corresponding parts of congruent triangle, and we could use the same reasoning we used on the other one, right? As to why angle B is congruent to angle A, right? Aren't they same side interior angles again? Okay, so, any question? Does that make sense? Good. Next, what I want to talk about is median of a trapezoid. Before I do, though, do you guys remember medians of something else? Medians of a triangle. Austin, do you remember what a median of a triangle was?
The line that from a vertex to the midpoint.
Exactly. Very good. From a vertex to the midpoint of the other side, right? Very good. Now, anyone want to guess what a median of a trapezoid might be then? Young, what do you think?
It's parallel to the base.
Okay, that's actually, we're going to prove that. You're right. But let's first describe what it is. How are you going to describe the median of a trapezoid? What do you think?
From the midpoint of the legs.
Exactly. It basically goes from midpoints of the legs. Right here, write this down. That's a definition. So do you see the difference? Even though it's sort of, right, they're called the same thing. Do you see the difference? Median of a trapezoid is the segment that joins the midpoints of the legs. Whereas for a triangle, it goes from vertex to the midpoint of the other side. Does that make sense? So please note the difference. But you're right. Young, in a minute, we're going to show that Mn is going to be what you just said. Okay. Anyway, let's hold on to that for a second. So as you can see, the Mn is the midpoint of the trapezoid PQRS, and then AT is the median of the triangle ABC. And even though they're called the same, sort of different, very different than the median of a triangle and the trapezoid. Okay. What do you suppose we're talking about medians of trapezoid? And you want to take a wild guess? Why do you think we're talking about medians of trapezoid? Yeah.
Or theorem.
Yeah, we're going to talk about a theorem that involves medians of a trapezoid. And Young said it first. That turns out that median, that Mn is going to be parallel to the bases, PQ and SR. Okay, so that's first part. Actually, and there's a second part. Let me actually move this up. Give me a sec. Let me move it up a second. So you're right. It is parallel to the bases, SR and PQ. Actually, it's going to say one other thing about in terms of length. Mn is, so you could actually figure out the length of Mn. Two people. Tony, what do you think?
SR plus PQ divided by 2.
Exactly right. Turns out, Mn, yeah, Mn is the length of the, Mn has the equal length of the average of the bases. In other words, like Tony said, if you were to add up SR and PQ, and you divide it by 2, that's how to find the average, right? It turns out that's the same exact length as Mn. So for example, if the length of SR was 1, and if the length of PQ was 3, what would the length of Mn be? 2, right? It's the average. It's always true. Okay, and in a minute we're going to actually think about how we're going to prove this. Okay, any question? Do you understand what it's saying? Okay. Yes.
So PQ divided by SR is Mn.
No. That's what it. Look what it says right here. Mn is equal to
Oh.
half of sum of the two bases, SR plus PQ, divided by 2. You got to add these two together first. You find the average of the two lengths. So Mn happens to be the average of the sum of the two lengths. Okay? Are we okay with this? Anybody need more time to write? People still writing. Let me wait. Yeah, people still writing. We're gonna think together in terms of how we could prove this theorem. By the way, does anybody see a similar theorem that you've seen before? It's not exactly the same. Okay, some of you? Go through your notes. Go ahead. I'll wait. Look through your notes. See if you can figure your. Okay, go ahead. I'll wait. Go ahead, look through your notes. Who thinks they have it?
I know.
All right. How about someone I haven't picked today? How about Josh? Go ahead. Which theorem seems? Yeah, it doesn't have a name. Right? How is it cut? How does it cut through the triangle? Midpoints of the. Yes. You guys remember this one?
Oh, we did that.
Do you guys remember this one where if you have a triangle, and then how is MN? By the way, is this MN a median of this triangle?
No.
No, it's not. Be careful, it's not. Okay. It basically connects the midpoints of each side, doesn't it? If you do this, right? Then what do we know? MN is parallel to BC, and MN is half of BC. But of course, you see how it's sort of similar to the one that we just talked about in terms of trapezoid? Of course, for a trapezoid, you have two bases, right? So instead of saying half of BC, it is half of the, sum of the two bases. But MN, this one was parallel to BC, and then, you had a trapezoid, it was parallel to the top base, okay? But turns out this theorem is going to help us prove the theorem that we've been talking about, this one. Yeah. We're going to draw an auxiliary line. Let me show you actually how we're going to draw this, okay? There are many ways, okay? So, turns out there are many ways of doing this, but we could use this one. We're going to draw from S, we're going to draw ray SN and ray PQ so that it intersects at T. Okay? By the way, so knowing this, what does it sort of remind you of? What do you see here? Kevin?
MN is the segment that joins the two sides.
Yeah, you see the triangle SPT? Right? Do you see the triangle here? And look at MN is half of SP. By the way, is N the midpoint of ST? Do we know that yet? No, it would be great if we knew that, right? Because then we could actually apply that theorem directly. Then you would say MN will be parallel to PT, right? Which will be parallel to PQ also because it's a part of it. And you could say the other ones, okay? So let's take a look at this and how that previous theorem is going to be helpful for us to prove this, okay? Is that okay? Any questions? Do you see the triangle that we want? Okay. So let's take a look at this and see how this is going to be helpful, guys. So wouldn't it be great? Right now, let's look at what we have. So we know that M is, by the way, we have a trapezoid, right? And they said that MN is the median. So what do you know about SM and MP? Congruent. What do you know about RN and NQ? Congruent. Does that mean all four of these segments are congruent? No. Good. All right. And like I said, look at this theorem. If I could show this AN is congruent to NC, for here it'll be SN congruent to NT. Wouldn't it be great if I could show that? Then I could say what? That MN is parallel to PT or PQ, right? But we don't have that, do we? We can't use that directly. But is there a way to show that SN is congruent to NT? That'd be nice. There is? One person see it? Anybody else? Go ahead. I want you to discuss with your group. I'll give you time. Is there a way to do this? So, Chris, is there a way to show that SN is congruent to NT? How? Yeah, you have to prove that the two triangles are congruent. Which two triangles? SRN. You see this triangle up here, guys? SRN and which one? TQN, if you said SRN. Right? TQN, right? Is there a way to show that those two triangles are congruent? Because then if I could do that, yes, of course we could show SN. Of course we could say SN is congruent to NT because those will be the corresponding parts of congruent triangles. Okay, so we know that RN is congruent to NQ. That's good. We got at least one part right. Anybody see any other ones? How about, yes, Jonathan? Yeah, vertical angles are congruent, right? Which one here? This angle right here and? Yeah, is that easy? Okay, that's good. We got at least two things going on for us. That's great. Okay, now we need a third part. Esther over here, what do you think? Good. We know that SR and this whole thing, PT are parallel, right? So what do you know, Esther? Good. We know that SRN, right, very good. We know this SRN. Oops, okay. This angle is congruent to? Right here. Okay, yeah, you could show that. Listen, guys, hold on. Shh. It doesn't have to be those angles. It could be NTQN, RSN also. Same reason, right? But we don't need all three angles to be congruent, right? So we have what? By the way, would this angle help?
Which one?
S. Somebody will say, wait a minute, can we do NTQ instead of this angle here? Can I show instead of, okay, let me erase. Somebody said, wait, could we say, isn't this one angle, isn't that congruent to this? Can we use those angles to show that the two triangles are congruent? Yeah, why? Angle, side, that's fine too. It's because of the same reasoning, isn't it? But it doesn't matter as long as we show that the two triangles are congruent. So, I'm going to keep the ones that we had here. It doesn't matter, right? So we know that the two triangles are congruent, right? So then what do you know about SN and NT? These are the corresponding parts of congruent triangle. And going back to that theorem that we had before, right? What do you know about, look, M is the midpoint of AB. N is midpoint of AC, right? So what do you know about MN in terms of MN and BC? They are parallel. So we could say MN is parallel to what? Yes. And how do you know that, whoops, it doesn't want to erase. MN is parallel to PQ. Because PQ is part of that PT, right? Now, how do I know that MN is also parallel to SR? 1, 2, 3, 4. Because we need to say MN is also parallel to SR, right? Not only. Okay. All right, Kevin, what do you think?
SR is parallel to PQ.
Yeah, SR is parallel to PQ. MN is parallel to what? PQ. So what do you have? You can't use transitive property for parallel.
You can?
No, for parallel lines, you can. Transitive property is for congruence, not for parallel. Yeah, good. If two lines are parallel to the third line, then guess what? They're parallel. Does that make sense? You can't use transitive. Be careful. If two lines are parallel to the same line, then guess what? The two lines must be.
But they're all parallel.
Yeah. So we know that MN is parallel to PQ. We know SR is parallel to what? PQ, right? So what can you tell me about? Look, MN is parallel to the same line. SR is parallel to the same line. What do you know about MN and SR? They are also parallel. Okay, now that's great. But what we wanted to say next is, look at if you remember the theorem, that's not all we wanted to say, right? The theorem says, not only are they parallel, we know that this MN is half of PQ plus SR, right? So how it turns out, the previous theorem also is going to be helpful for us. So knowing this, you could actually prove that. So let me write it down. We want to show that what? MN is equal to half of what? PQ plus SR. Okay, so it turns out showing these two triangles congruent is going to help us to prove this too. One person see it? Two people see it? So knowing this, so we're done with we were done with part 1, right? So that's great. Part 2, how are we going to show part 2? Okay, I want you to think as a group. Go ahead, I'll wait. Alright, so who thinks they know how to show that MN is half of PQ plus SR? Like I said, where is it? Sorry? Oh, this is going to be helpful for us, right? So how is that helpful? Jason, what do you think, sir?
So MN is half of PT.
Good, let's write that down. We know that MN is half of PT from where?
That theorem.
Yeah, from this theorem, right? Isn't that what he said? Look, MN is half of the whole base, right? So this time the base is PT. Then what, Jason?
Then PT is PQ plus QT.
Yeah, isn't PT by segmentation partially? What's PT? PT is what? Nothing more than PQ plus QT. Okay. Then what, Jason?
And then SR is congruent to QT.
Yeah, we also know that SR is equal to QT. Isn't that right? Because those are the corresponding parts of congruent triangle. So what?
And then you substitute it.
You substitute what? in place of, so what's PT equal to?
Well, you can't use substitute.
PQ plus SR.
Yeah, these are actually length, right? These are length. So in place of, we know that PQ instead of QT, what are we going to write? What's QT equals to? So we're going to put that in there, right? So PQ plus SR. Isn't that what PT is, really? The same length, aren't they? Then you plug this into here, so you get MN is half of what? PQ plus SR. And isn't that what we wanted to show? Substitution. Okay, does that make sense? Any questions? Very good, Jason. Okay. Does this make sense? Okay, help each other out if they don't see it. Right? Okay, help each other out. Talk to each other. Go ahead. Okay, does this make sense, class? Do you see it's basically what's SR equal to? Length of QT, right? Because those are the congruent parts of, these are the corresponding parts of congruent triangle. So look, in place of SR, you could just plug in QT here. You see how that works out? Any questions? Do you guys understand the theorem now? Do you see what it says? Any questions? Yeah, that's it. Oh no, I know. Almost done. Okay, one more thing. Okay, so let's do one exercise. Here we go. Go ahead and try this example here. Can you find me, if I have a trapezoid and the median is shown, okay, can you find the value of x? Go ahead, I'll wait. Go ahead, everybody try. I'll wait. I haven't picked. Iveta, what do you think? How do I find the value of x? What sort of equation can you give me? Knowing from the previous. Iveta, can you give me the equation? Look, let me give you a hint. Isn't this 10, length 10, isn't that my median of this trapezoid? So what did we just say? Median of a trapezoid is equal to, class, listen, half of the sum of the base, right? So isn't that what you get, class? 10 is equal to half of sum of the base, which is 2x minus 4 plus x minus 10. How many people got the answer as 9? Any question? How many people got the answer as 9? Raise your hand. You guys all got this? Any questions? Okay, no questions. Can you do something like this for your homework? Yeah. All right, good.